So let's remember, why are we learning how to use this summation notation? We are going to have to be able to find the area under a curve. The curve could be curvy, and we're going to divide that area under the curve into many, many, many small pieces. And we are going to have to add up all these small pieces. And that curve is given by a function. So we need to know how to apply summation formulas into functions, which is where we're going to go next. So it'll be helpful to be able to break down these functions by applying some properties of summation. All right, so here's some basic properties of summation, and you'll be able to recognize some of them. The first one says that the summation from 1 all the way to n of something that has a constant, and then you have your formula for your summation, the formula where you're substituting the index. Well, something that you can do right away is just factor out the constant and then just find the summation of something simpler, all right, of your AI formula. That is the first property. And what does an example of that looks like? Something quite simple could be like the summation from I equals 1 to 5 of 2 times 3 plus I. All right, what is that equal to? We'll take the 2 out as a constant, and then you can find the summation from I equals 1 to 5, but only of 3 plus I. Ta-da. What does the second property says? The second property says find the summation from I equals 1 to n of something that looks like the sum or the difference of two formulas. Well, that is pretty easy. Again, you separate it into two summations, the sum or the difference of the two summations. What does that look like? Then as an example, let's see, the summation from I equals 1 of all the way to 2 of 2j plus j squared. What does that look like? Well, instead of trying to calculate, oh, bad notation, this should be j, ha ha ha. So this is equal to the summation. Oh, this is a constant as well. So you can hold out the constant 2 times the summation from j equals 1 to 2 of what? Of j plus, this is my second one, the summation from j equals 1 to 2 of j squared. So this way we can break up functions into smaller parts that we can actually find a summation. If I know what this is equal to, then I can write 2 times that. If I know what this is equal to, then I could write plus that summation. All right, in total. So this is how we're going to be doing. So there's some formulas that you need to memorize to be able to simplify your problems. All right, and ta-da, these are your summation formulas. There's 4 summation formulas. These are the first 2, and they follow something. The first formula is somewhat trivial, but here we go. This is saying that the summation from the first term all the way to the end term of a number. If I just give you a number here in a formula, what is that equal to? Well, that is equal to this number that I gave you times n. Where are you going to your summation? C times n, where C is a constant. How does that look like? Well, this is the summation from I equals 1 all the way to 5 of 7. Well, what does that say? Remember, we're substituting this I into our formula. All right, my formula actually happens to be 7, so there's nowhere for me to substitute the I, but I still have to continue doing these iterations in my formula. All right, so what is my first term of the sequence? Well, let me substitute I into my sequence, and my first term is just 7. What is the second term of the sequence? Well, now I'm at I equals 2. Let me substitute that 2 into my formula, and this is only 7. And 7 again, and 7, and 7. And it turns out that we have 7 times 5, which is 35. All right, so it's a really nice trick. Instead of doing this whole expansion, we can just apply this formula and get our final answer. Our second example is a really famous one. This one is nothing but just saying, what is the summation of the first n integers? You can go to your friends and just be like, yo, tell me what's the sum from the first integers from 1 all the way to 250. And boom, you know, they won't know how you do it, but you did it. This is how you do it. This came from Gauss. He's a mathematician. When he was younger, there's a funny story about him, and I will go ahead and explain that in a separate video. But what is this equal to? All right, it's saying that if I'm asking you to add up the first integers, all you have to do is do this formula. Example, what is the summation from the integers from 1 all the way to, let's say, 7? Well, what does that become? Yeah, of I. Well, it's 1 plus, let me substitute into the 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. Whew, and this is a total of 28. All right, but that's if we do the expansion. Why do the whole expansion when you know a formula for your expansion? This is the same thing as if I would have said, what is my n value? When my n value is 7, all right, so it's 7 times 7 plus 1 over 2. 7 plus 1 es 8, 7 por 8 dividido entre 2. 8 divided by 2 is 4, so it's 7 times 4, which is 28. So the same. All right, the third formula is just saying add up the first integers square. So something really simple, that in the summation from I equals 1 all the way to 5 of I squared is equal to, well, we would do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, and the answer is equal to 55. Too complicated, way too much. What if I ask you to find the sum of the first 100 terms? You would not be able to do that. Probably you would, but it would not be ideal. Well, let's just use our formula then. We need to identify n. N happens to be 5, all right? So let's do 5 times 5 plus 1 times 2 times 5 plus 1 over 6. And the result of this is also 55. All right, this is the last formula for sums. Formula number 4 says, that the summation of all the cubes is equal to this formula right here in terms of n. All right, so an example will be, what is the summation from I equals 1 to 4 of all the cubes of I cube? All right, well, let's just plug in the n value, and 4 squared, 4 plus 1 squared over 4 is equal to 16 times 25 over 4. 16 over 4 is equal to 4, so it's 4 times 25. The result is 100. You can go ahead and verify that by expanding, but remember the formula is way easier if I ask you to give me the summation of the first 100, 1000, 10,000 terms. Imagine that, crazy.